In this video, I'm just going to go over some examples of solving first-order linear differential equations. These are going to be straightforward. There's just more examples so you can kind of model your problems after some of these. So direction simple, solve. First one, y prime plus y equals 1. Please notice this is in the form y prime plus p of x times y equals q of x. Therefore, p of x is going to equal 1. Q of x also equals 1. And we know, since this is in standard form, we can just go ahead and find our integrating factor. So this is going to be e to the 1 dx, which is just e to the x. So this is our integrating factor. So I'm going to take that and multiply everything by it. So we got e to the x times y prime plus e to the x times y equals e to the x. Note we have the product rule on the left-hand side. So we're just going to rewrite this as our integrating factor times y equals e to the x. Next, all we have to do is integrate both sides to give us e to the x times y equals e to the x plus some arbitrary constant. And finally, to solve for y, we divide everything by e to the x, to give us y equals 1 plus, we'll say 1 plus c e to the negative x. And there's our first example there. In our next example, we need to be careful. The reason for that is we have 4x to the third times y plus x to the fourth times y prime equals sine cubed x. Now the reason why I said we got to be careful is I know initially we're sitting there and you may be looking at this and saying, okay, it's not in standard form, I got to get it in standard form. But remember, the whole process of our method to solve first order linear differential equations is that we want to get the product rule on the left-hand side. And if you look at this, we already have that here. This is the product rule. It is the product rule between x to the fourth and y. So, you know, it's in your best interest to understand the method we are using, not to memorize each individual step. All right? I know that's easier said than done, but you know, that's the big thing with math. It's understanding how the problem comes to life, or understanding the method that we are trying to teach. So here, we're just going to go ahead. We're going to integrate both sides. That gives me x to the fourth y equals. Now, on the right-hand side, you got to be careful because this is sine to the third x, which means we got to go back into our trigonometric integrals all the way back to the beginning of the semester. And what we're going to do here is we're going to take out a sine x. We're going to rewrite sine squared x. All right, we're going to rewrite this middle right here. We're going to rewrite that as 1 minus cosine squared x dx. Now, we let u equal cosine x. du equals negative sine x dx, so we'll put the negative on the other side. So this is going to be x to the fourth y equals a negative out front times the integral of 1 minus u squared du. So this is x to the fourth y equals a negative out front, u minus 1/3 u plus c. All right, I guess we don't need these parentheses anymore. That's going to give me x to the fourth y equals, well, no, we needed the parentheses there because now I got to distribute. I'll do it all in one. Negative cosine x plus 1/3 cosine cubed x. I'm just going to put plus c even though it's minus c. We don't know what c is, so we're just going to write plus c. That's fine. And finally, divide everything by x to the fourth to give us y equals negative cosine over x to the fourth plus 1 over 3x to the fourth times cosine cubed x plus c, we'll leave it like that, c over x to the fourth. So there's that answer right there. In this next problem, we will do an initial value problem. So let's do x times y prime equals y plus x to the second times sine of x with initial conditions y of pi equals 0. So the first thing we want to do here is get this into standard form. So what we're going to have to do is subtract y from both sides. Okay, that's going to give us the following. And then divide everything by x. So that ends up giving us y prime minus 1 over xy equals x sine x. So that's the first thing we have to do. Now, right here is p of x. So let's go ahead and find our integrating factor. I'm going to put I dot f will be e to the integral of negative 1 over x dx, which I'm going to pull the negative out front. All right, we know the integral of 1 over x dx is going to be the ln of x. All right, but because you have this negative sign out front, we're actually going to move that up as the exponent, and you end up getting 1 over x as an integrating factor. So we're going to take that, and we're going to multiply everything by 1 over x. In fact, how about I do this? I'll write it in pink, so we know that's what we're multiplying by. All right, so that's what we have here. Now let's clean this up a little bit, okay? So we're going to get 1 over x y prime minus 1 over x to the second y equals sine x. And when you look at this, what you really have is x to the negative 1 times y prime minus x to the negative 2 times y equals sine x. And right here is our product rule. It's the product rule between our integrating factor and the variable y. All right, and that equals sine x. So what I'm going to do here is just rewrite it over here. Just rewriting it. And now we're going to go ahead and integrate both sides to give us 1 over xy equals negative cosine x plus c, which we can easily solve for y by multiplying everything by x to give us y equals negative cosine x. I'm sorry, y equals negative x times cosine x plus c times x. And now we can go ahead and apply our conditions. So wherever we see an x, we're going to put pi. Wherever we see y, we're going to put a 0. So you get 0 equals negative pi times the cosine of pi plus c times pi. And when you go ahead and solve this, you're going to get c equals negative 1. So our final answer will be y equals negative x cosine x minus x for our final result. Okay, in the next question here, we're going to do a voltage problem. And just remember, Ohm's law gives the drop in voltage due to the resistor as Ri. What we're going to learn right now is Kirchhoff's law. So real quick, in the circuits shown below, a battery supplies a constant voltage of 40 volts. The inductance is 2 henries. The resistance is 10 ohms. And I of t, in this case amperes, at any time t is going to be I of 0 equals 0. So Kirchhoff's law, make sure I spell his name correctly. Basically states this relationship. So when we read this on the left-hand side, this is our voltage drop. This is part of Ohm's law that says voltage drop is due to a resistance times its inductance, or its current. And Kirchhoff says that the sum of the voltage drops is equal to the supplied voltage. Okay? So with our problem up here, all right, we're going to do this in like 2 steps. All right? The first thing that we're going to want to look at is part A. We want to find I of t. We want to figure out, since this is a differential equation, what is that mysterious function of I? So to do this, all we have to do is just kind of write down what we know and then go ahead and solve. So from our problem, we know L is equal to 2, R is equal to 10, and the supplied voltage is 40 volts. That just came from up here. Let me go back up. So here's our supplied voltage, here's our resistance, here's our inductance, and 10 ohms is our resistance. So we can go ahead and just take these values and substitute them into Kirchhoff's law. So we have 2, that's supposed to be an I up there, di dt plus 10i equals 40. And the first thing I'm going to do is look at this and say, okay, well, this is a linear first order differential equation, but it's not in standard form. So let's go ahead and divide everything by 2 to give us di dt plus 5i equals 20. So here is the problem that we need to find, here's the problem that we're going to find, I of t. So to do this, integrating factor is going to be e raised to the 5 dt, which is just e to the 5t. So there's our integrating factor. We're going to multiply everything by that. There we go. On the left-hand side, we got our product rule. So this is going to be dt, or ddt of our integrating factor. And in this case, it's going to be I equals 20 e to the 5t. Now when I go ahead and integrate both sides, on the left-hand side, I get e to the 5t times I equals, on the right-hand side, I end up getting, let's take this and move it out front. Then let's go ahead and integrate. E to the 5t, you need use substitution. So we'll move the 5 over here. So it's just going to be e to the 5ti equals 4 times the integral of e to the u du. Now I got the 4 because it's 1/5 du, so it's like 20 divided by 5, which is 4. So this just turns out to be, oh, that looks terrible. I'm writing too fast. E to the 5t I equals 4 e to the 5t plus c. Finally, I'm going to go ahead and divide everything by e to the 5t. So I equals 4 plus c e to the negative 5t. So this is what I of t is, but we do have initial conditions. We know I of 0 equals 0. So substitute in your zeros, and solving for c gives us c equals negative 4. Therefore, I is going to equal 4 minus 4 e to the negative 5t. Okay? So there's our first result there. There's I of t. Now, if we were interested in finding out like what the current is after any amount of time that has progressed, we have our equation right here that actually models that for us. So part B, let's just find the current after t equals 0.1 seconds. So all we would have to do here is just make our substitution. For t, and we'd come up with, after 1/10 of a second, the current is approximately 1.57 amps. And that's going to be it for this video. I hope you found these examples to be very straightforward. That's exactly how this section is. Just understand the method, do not memorize. On that note, I'll see you in the next video.